A very good morning, students. In this video, we will be discussing the time and space complexity of an algorithm. In the previous video, we have briefly touched upon the idea of time and space complexity. Here, we will discuss them in substantial detail. I won't say completely because there are a lot of concepts and we will go slowly discovering the concepts one after the other. So let us begin with the definition. In very simple terms, if we have to define the time and space complexity, then time complexity is how fast an algorithm runs for an input of size n. That means the speed of the algorithm for the given input size. And the space complexity will be defined as how much extra space an algorithm requires. Let us look at these two definitions in greater detail. So, time efficiency. Now, in order to calculate the time efficiency of an algorithm, we have to execute. But the algorithms don't execute. That means we have to implement a program for that algorithm, run it and find out how much time it is taking. But even if we do all this, is it sufficient? Because there are a lot of other factors which are independent of the algorithm. For example, the speed of the computer on which the algorithm's program is running. Now, even if you write the fastest algorithm, the fastest program, if the computer is very slow because its CPU doesn't have the power to execute a lot of instructions per second, then no matter how fast the algorithm is, it will execute slowly. Another thing is the quality of program. When you write an algorithm, you discuss the concept. Okay, this is to be done in a loop. Here the comparisons have to be performed. But how the programmer is converting that algorithm into a program and what is the quality of that program, that might be different from the quality of the algorithm because each programmer has their way of implementing the algorithm. Then it might be difficult to clock the actual time of the algorithm because the computer's response time, it includes everything, the waiting time, the process is in the input waiting queue, in the CPU waiting queue. So all these times, they are not the time when the program is executing. So the algorithm's complexity will also get influenced by this. Therefore, executing a program is not the solution to find the complexity of an algorithm. Then how do we do it? One possible approach is that we count the number of times each algorithm's operation is executed. Now, within the algorithm, there are a number of steps and we count how many times each step is getting executed, and that becomes the complexity of the algorithm. And even better will be to identify the most important operation of the algorithm known as the basic operation, and then the time taken by the basic operation will become the complexity of the algorithm. So in a sorting algorithm, the place where the sorting is actually done after all the input is taken, that is where the basic operation is getting performed. Now let us look at some examples to understand this better. Before looking at the example, there is another factor which influences the speed of an algorithm, and that is what is the size of the input on which the algorithm is working. Now, if we want to sort an array and if we have a large array, then definitely the program is going to take more time as compared to it will take for a smaller array. So therefore, it is logical to investigate an algorithm's efficiency as a function of a parameter n, where n indicates the algorithm's input size. Alright, then moving ahead, the space complexity. Now space complexity is the amount of space required by a program or an algorithm. Now there is a fixed space. Fixed space is that part of the algorithm which includes the instructions itself, the space taken by code, local variables, constants, etc. And there is a variable space. Variable space is influenced by the input size, depth of recursion or function call, and it is determined at the runtime. Now let us look at the examples of time and space complexity calculation. We will be discussing very small examples just to get the idea across. The kind of questions that you will get in the exam are going to be much more difficult than what we are doing right now. But this will fix the idea in your mind. That is why we are doing very small examples. So the first example, here we have an algorithm, sum, which is calculating the sum of two numbers which are not even stored in the variables. And we have to calculate the complexity of this algorithm. Now, how many operations are getting performed in this particular algorithm? There is a return statement and there is a plus operation. So there are two operations, and therefore the TP, that is the time complexity of the algorithm, is 2. And how much space is getting used here? These are going to be stored in the temporary memory and will be directly loaded into the registers, and therefore the space complexity is going to be 0. Moving ahead to the second example, again we have an algorithm sum which is receiving two arguments A and B, and then we are adding those two variables into a C and then returning that value of C. Now here the time complexity is, there is a equal to operation, one operation, there is a plus operation, two operations, and there is a return operation. So there are 3 steps in the algorithm. And as far as the space is concerned, there are 3 variables, therefore the space complexity is 3 variables. Moving ahead, yet another example. In this algorithm, we are calculating the difference between A and B. But we have attached an if condition that if A is more than B, then A minus B should be done, otherwise B minus A should be done. Now this operation will always be performed. It might be true sometimes, it might be false, but every time we call this algorithm, this operation will definitely be performed. So it is a one step. Now out of these 2 steps, either A minus B or B minus A will be performed. Now in both the cases, only one of them will get executed. So there are 1 and 2 operations, and here also 1 and 2 operations. So for all this code, only 2 operations will get executed. So 2. And then the return operation, so 1 operation. So total of 4 operations are there: 1 comparison, 1 subtraction, 1 assignment, and 1 return statement. And coming to the space complexity, there are 3 variables involved, so the space complexity is 3. Moving ahead, let us take an example of a for loop. Now here we have to calculate the sum of the elements in an array A with a size of n, and the sum will get deposited in a variable S. Now initially the sum is 0. Now we are executing a for loop from 1 to n with a step size of 1, and in this for loop we are calculating S is equal to S plus A of I, and in the end we are returning S as the answer. Now here this assignment is going to take 1 operation. This for loop, the assignment I is equal to 1 will take 1 operation. Then every time the n will be incremented by 1, so for that n times the increment will be performed, and then the comparison will be made whether the value of I is less than equal to n, and for that we will have the comparisons from I is equal to 1 to I less than equal to n, because the last time when I is equal to n, the loop will become false and we will break out of it. And then the return, this particular operation, this has two operations. This statement has two operations, but how many times these two operations will be performed? Because it is under a for loop, so that number of times the for loop will execute, the same number of times these operations will be performed. Therefore, its complexity is 2n. And the return statement has a complexity of 1. So what all do we have? 1. We have 2n plus 2 for this for loop. 1 plus 1 plus n plus n is 2n plus 2. For this we have 2n and for this we have 1. So now add all these. So we get 1 plus 2 plus 1, 4. And here we have 2n plus 2n, 4n. So the total time complexity of the algorithms becomes 4n plus 4. And the variables, how many variables are involved? There is a variable n, there is a variable I, there is a variable s, then there is an array of size n. So there we have n plus 3 variables. So n plus 3 is the phase complexity of this algorithm. So let us stop here. Take some time to absorb this idea so that when we do more examples, the concept is clear in your mind. Thank you.